All right, homework handouts out, and all about Robin Hood. All of this is fictitious, of course, but so is he. All right, at least we think he was. Number 1, Robin Hood wins an archery competition, hitting the bullseye of a target 50 meters away. His arrow flew to the target in 0.62 seconds. How fast was the arrow traveling? And what do we write down here? The 50 meters, what is that, class? Good, Kendall, displacement. And the 0.62 seconds, class, that's time. And it says how fast was his arrow traveling? Well, that's looking for the velocity. The initial or the final? Just kind of all of it, or we would say the average velocity. And what equation do we need to use to find how fast the arrow flew to the target? Michael?
VAV equals D over T.
There we go. So we just take the 50 divided by the 0.62. And what did you get for your answer, Michael?
81 meters per second.
You had 80.6 dot, but rounded only the 2 sig figs from right here, 81 meters per second. Ladies, did you also have 81? 80.6. Okay, 3 sig figs instead of 2. Okay, careful with sig figs. Questions on number 1. Number 2, the Sheriff of Nottingham challenges Robin Hood to see how high he can shoot an arrow into the air. Robin releases an arrow straight upward at a rate of 89.5 meters per second. How high will the arrow rise? So the only number they give us is 89.5 meters per second. And Audrey, that's the
initial velocity.
Not the average velocity? It doesn't stay going 89.5? Why not?
Slows down.
Why does it slow down?
There's a point at somewhere in there that it slows down.
But why? Why would it slow down? Why not just keep flying along merrily?
Because
Or flying along merrily, I should say.
it has to come back down.
Why?
Because gravity.
Gravity, that's what I was looking for, that word, gravity, right? So that's only the initial velocity, because gravity, class, does what to the arrow? Pulls it down, slows it down, or eventually stops it, decelerates it, right? So we also know the acceleration. It's not mentioned in the problem, but we know our acceleration's what, Audrey? There we go. It asks how high can he shoot the arrow, class? So we're finding the... And there's one more number that is suggested to us, though not necessarily spelled out, Audrey. The final velocity, and we're not talking about the final of it goes up and comes back down. We're just looking at the trip upward, right? The final velocity at the top of the trip up, once it's reached as high as it's going to go, is 0 meters per second. Which equation did we need to use this time, Kendall?
V sub f equals v sub I plus 2ab.
You're really close, but there's something very, very important you forgot, class. Squares. VF squared equals VI squared plus 280. So, right idea, just forgot about the squares. So, as I'm solving for the displacement, Kendall, what do we need to do?
You subtract the v sub I squared, and then you divide away the 2a.
All right, so now the VF was 0 anyway, so if we didn't square it, it didn't really matter. Oh, there is still a negative here, by the way. But we do need to square the 89.5 and then stick a negative onto that. So we get negative, big number, whatever 89.5 squared is. Fortunately, though, the A is also already negative. So if you wanted to, you could think of the two negatives as just canceling. But it's still 89.5 squared divided by the 2 times the 9.8, or divided by 2 and then divided by 9.8. What should we have had, Kendall, for the height that the arrow will rise?
817.
You forgot to divide by the 2. You divided by the 9.8, you forgot to divide by the 2 also.
408.
Point
0.68.
blah, blah, blah. How many sig figs?
3.
3, so we'll round to...
409.
And the displacement measured in meters. How many had 409 meters up into the air? 409 meters up into the air. Ooh, okay, questions? Questions? Anyone have something like 4 point something?
I forgot to divide by 2.
You forgot to divide by 2, so you had 800 something.
I just didn't square
You had 200 something. You divided by 2 a couple times, maybe. I don't know. You had to have squared, though, because you never would have got an answer that big without squaring. So you remember the square, just something else went screwy. Questions? All right, number 7. From problem number 6, so using all of this information, in fact, possibly even using this, though we'd like to avoid using it if we can. Assuming the arrow, which went straight upward, returns straight downward, how long will it take the arrow to come back down to Robin Hood? Though he should probably not try to catch it in his teeth, though that would be awesome, right? It's something the movies are made of, right? But anyway, total time in the air. Well, we can't find total time in the air directly, class, since all of this was dealing with just going up. So really what we need to find is we need to find the time up. But how would I find total time after I found time up, anyone? Just double it, right? What comes up must come down. We found that the time up and time down would be the same if we had neglected air resistance, which of course we have to anyway. So we'll just double whatever our time up is. Can we get by without using the displacement? Is there a way to do that, Audrey? Is there an equation that uses these without using D? The acceleration equation, good, but we'd want to alternate, wouldn't we? And we'd say that VF minus VI over the A is equal to the T as we swap the T and the A, alternate them. Again, the V sub F is 0 anyway, so it's really just the negative 98 or 89.5 divided by the negative 9.8. And what does that give just for the time up, Audrey?
29.13.
Good, but then we want total time, so we'll double that, multiply by 2, and we end up with
18.265.
blah, 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 rounded to still 3 sig figs, because that's all we were given was these two numbers, so.
18.3
And time measured in seconds. How many had 18.3 seconds for number 7? Anyone left with this a 9.13, just forgot to double it. All right, does that make sense now? All right, questions on number 7. Number 8, after the archery competition, Robin Hood rides away at 14.7 meters per second, pursued by the sheriff. Unfortunately, he's surrounded and has to suddenly bring his horse to a halt. If the horse came to a complete stop in 5 seconds, what was Robin's deceleration, assuming he was not thrown from the horse? So the 14.7 meters per second, Michael, that's the
Initial velocity.
the 5 seconds, of course, is time. And we're finding it says it's deceleration, so we're actually finding A, acceleration. We just know our answer, class, is going to be negative, okay? And there's one more number that's suggested, Michael.
The final velocity.
Final velocity is 0 because it brings the horse to a stop. So what equation do we want to use that relates these variables?
Acceleration equation.
Acceleration equation, just straight up, as we would have expected to use it. Again, the final velocity is 0, so we just take a negative 14.7 divided by 5. And what do we get?
Negative 2.94 meters per second squared.
And I believe that already came out to the 3 sig figs, if I'm not mistaken, and that's how many we wanted anyway. How many had negative 2.94 meters per second squared? Questions on the handout? Any questions? All right, set it aside. We used acceleration equation twice. We used average velocity once. Though there's another way to find average velocity. It's kind of a duh way to find it because you're averaging velocities. But what would that other way be to find average velocity? Anyone?
1/2 VI plus VF.
Yeah, add them, VI plus VF, VF plus VI, doesn't matter, additions community. Add the final and initial, cut it in half, there's your average. The only other equation was if we wanted to find how far Robin Hood traveled from the time he started pulling on the reins to the time the horse finally came to a stop. How far did he still actually go in that time? Displacement during an acceleration or deceleration. And it's a little bit of a longer one. Volunteer. I think Audrey gave us all of them last time, so one of you two. Kendall, thank you for volunteering. I saw your eye move. All right, what'd you get?
B sub I T plus 1/2 AT squared.
Very good. There, V sub I T plus 1/2 AT squared. It's like in an auction, right? Any movement at all can be construed as, oh, your earring jiggled. Yes, I got 50. Anyone got 55? 55. Yes, ma'am, you just laughed. 55. Anyone got 60? Anyway, questions on this? All right, clear desk except for a clean sheet of paper and a pencil and a calculator. Clean sheet of paper, pencil, calculator, and everything else away. Paper, pencil, calculator, everything else away. And first last name at the top of your paper, along with today's date. First and last name at the top of your paper, along with today's date. Today is 10/3/22. 10/3/22. First and last name, 10/3/22, today's date. And this is quiz 8. Quiz 8. All right, let's take a look at the quiz together very quickly. Numbers 1, 2, and 3. I'm asking you to write out your equations, or 3 of them at least, and I've given you some certain things. You may want to kind of convert those into variables and then tell which equation has those things in it. Number 4 and 5, some questions for you to answer. And then 6 and 7 are connected, and 8 and 9 are connected. So once you get your answer to 6, I'd recommend putting it in the memory of your calculator, just in case you wanted to use it or needed to use it. 8 and 9. Once you get 8, save that and use that there in number 9. For the record, the .22 is not a number you will use. That's just a Calibro of bullets. So do not attempt to use .22 in your math anywhere. All right, you may begin.